I get it. So listen carefully. Now, this is an aspect of organic chemistry. So virtually, I want to name organic compounds. So how do I go about naming an organic compound? Now, I'm not starting afresh. I'm starting from a particular place. So all I wanted you to do, I know you guys are familiar with how you can name or how to name organic compounds. But here, this particular example seems very strange because of the multiple functional groups we have. Look at it, this is a functional group, this is another functional group. The question is, don't forget, there is a rule. Following that rule, if you decide to follow the rule, some of you get confused. The rule is always consider the longest carbon chain. By considering the longest carbon, fine, we have 1, 2, 3, 4, 5, have it? 1, 2, 3, 4, 5. I guess I can consider the whole of this. So I'm considering this long chain. I can give you, this is a condensed structure. I can decompose the structure. By the time I decompose the structure here, it looks like this. Carbon attached to 3 hydrogen. 1, 2, 3. Then carbon again to 1 hydrogen. Then a methyl. Then the next one is carbon again. 1 hydrogen with a double bond. Carbon, a single bond, hydrogen. Then carbon attached to 3 hydrogen again. So after which I have to name this compound. So how will I go about this naming? So naming a compound like this stuff is easy. Now there's something you have to do. There is a list known as the priority. So considering the priority list, in that priority list, the first thing you have to consider in the list is the carboxylic acids, followed by the alkanals or the aldehydes, followed by the CO, the alkanones, followed by the ol, followed by the triple bond, the double, then the halogens, whether chlorine, bromine, iodine, fluorine, and stuff. Then the alkyls, methyl, ethyl, propyl, and stuff. So this is the priority list. This one tells you that if this and this appears in a single structure, now in that list, you have to consider the carbon. Don't forget, according to the rules, after considering the longest carbon chain, the next thing is you consider the carbon, or you number forward, number backward. Then you consider the carbon closer to the functional group. Now my point of emphasis is considering that point, or considering the carbon closer to the functional group. By chance, if you want to consider the carbon closer to the functional group here, automatically I have a problem. There are 2 functional groups here. If I say I want to consider carbon closer to functional group, to this one here, I'll consider this because I know this is closer to this, but this one is a bit far. But if I want to consider this one, I notice this is very close to this, but this one is a bit. So automatically that alone is a problem. So the question is, which one will I consider? Which one will I consider as a functional group in this case? Now in this case, you have to follow the priority order. And the order says, anytime you have this and any of them in the structure, you consider this one. Anytime you have this one and any of them in the function, consider this. Anytime you have this and any of them, consider this. So that means in this particular structure. Now, after considering the priority order, the next thing I can name the compound. That means in the priority order, I guess this one comes before this. So I'm going to consider this. You understand? This will be my point of emphasis, the double bond. So I'm going to consider the carbon closer to this double bond here. So that means by the time I number from the front here and number from the back here, I notice my second numbering, you understand, the reverse numbering is closer to this particular thing here. So that means I'll number from here 1, 2, 3, 4, and 5. And then naming this compound, see how the name goes. Now, don't forget, this is an alkyl group, particularly methyl. And the methyl is on which carbon? It's on the 4th carbon. So this particular compound takes the name 4-methyl I need to state the position of the methyl, you understand, in that structure. So the methyl is on the 4th carbon. That's why it is 4-methyl. 4-methyl what? Now an hydrocarbon with 1, 2, 3, 4, 5 with 5 carbon is pent. Are we together? Now don't forget, there's a rule. Anytime you notice a single bond in a structure, you understand, then that compound is going to have an ending in A-N-E. When you notice a double bond, it's going to have an ending in E-N-E. Then a triple bond have an ending in Y-N-E. So this is alkene, this is alkynes. So that means because of this double bond here, this particular compound is going to have an ending in E-N-E. So this is an alkene now. So that I have 4-methyl pent. Don't forget, I know you should know why I'm having a pent here. An hydrocarbon with 1, 2, 3, 4, 5. 5 carbon is pent. Pent. Now, you need to tell me the position of the in the structure. The in is on the 2nd carbon, as you can see. So this is 4-methyl pent 2 in. And that brings us to an end of this particular thing we are doing here. But considering the second example, I guess the second example seems a bit complex. Let's see. You have carbon, then this is what you have. Or let me just use this particular place. Now see what I have here. By the time you notice the rule says consider the longest possible chain. By the time I decide to consider the longest possible chain, by the time I number in this manner, 1, 2, 3, 4, 5. You understand? If I consider this, I have 5 carbons here. By the time I go in this manner, let's see. You have 1, 2, 3, 4, 5, 6. I have 6 long chain. Look at this one. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. From the look of things, I notice I have to move like this to get my longest chain. 1, 2, 3, 4, 5, 6. I guess that's my longest chain. So from the look of things, let's decompose this one. So by decomposing this is CH3 now. So we have C, 1, 2, 3. Then followed by C attached to 2 hydrogen. 1, 2. Then C. Then I have 2 methyls here. This is CH3, CH3. Then carbon to a chloro, double bond, chloro again. Then carbon. Now this is what I have. Now with this I can equally name that compound. So to naming the compound is quite easy. So now if you consider the priority order or the priority list, you notice in that list, this one comes before this one and this one in that list. These ones are the halogens. This is a chloro group. And this one is an alkyl group. So if you consider the priority order, the double bond, that's the alkene, comes first in that order. So I'm going to consider the carbon that is closer to this particular thing here. So by so doing that, let's see. If I number it now, I have 1, 2, 3, 4, 5, and 6. So I guess, and you are going to name, let me give you the rules all together. Now the first thing is you consider the longest possible chain, the longest carbon chain, after which you number in the forward direction, number in the reverse direction, and consider the carbon that is closer to the functional group. After which you name alphabetically. Name alphabetically. Now, according to alphabet, I believe this one is chloro, this one is methyl. That's C, M. From the, you understand, in alphabet, I guess C comes before letter M. That means I'm going to name this one first. After which this one will follow. After which I end it with the in. So if I follow that route, let's see what happens. I guess the chloro I have here, the first one is on the second and the third one is on the third carbon. So that this particular compound have the name 2, 3. Now you must tell the examiner or you must notify the examiner that there are 2 chloro groups here. 2, 3 by introducing a dichloro. 2, 3 dichloro. You understand? I'm done with this one. Let me go for this. I guess I have a methyl, and the methyl are on each carbon, on the same carbon. Both of them are on the 4th carbon. So this is 2, 3 dichloro, 4, 4, 4, 4 dimethyl. you need to indicate, make the examiner understand that there are two methyls there. The first one is on the fourth, the second one is on the fourth as well. That's 2,3-dichloro-4,4-dimethyl. Dimethyl what? Now I will come up with 1, 2, 3, 4, 5, 6. 6 carbon is X. So this is X. Now because of the presence of this double bond here, this compound is going to have an ending in ENE. That's an ene. This is an alkene now. So that's 2,3-dichloro-4,4-dimethyl X. Now tell me, you need to tell me the position of the ene in that structure. I guess the ene is on the second carbon. That's 2,3-dichloro-4,4-dimethyl. Dimethyl was X. Now where is the position of the ene? Is on the second carbon. X2 ene. So, and that brings us to an end of this particular thing. Thank you very much. God bless you.